Hi everyone, my name is Tristan Colgate. I'm the Managing Director and founder of Fidenda, and we're an Anaplan consultancy here in the UK. I'm here to tell you today how I built a solution using Anaplan Optimizer for the world's hardest Sudoku challenge. So I'm sure most of you played Sudoku before, but let's just have a quick recap of the rules. So, as we know, Sudoku starts with the following. We have a 9x9 grid that is subdivided into 9 3x3 grids. And within this grid, we have digits. And we can have digits from 1 to 9. And when we're presented with a Sudoku challenge, we're presented with what you see here. Some of those numbers are filled in. It's then our job to fill in the remaining numbers following certain rules. And those rules are quite simple. We have to enter a digit between 1 and 9. We have to make sure that in any given row, all digits through 1 to 9 appear and only once. Similarly, with any given column, all digits 1 to 9 appear and only once. And finally, within any given 3x3 subgrid, all 9 digits appear and only once. And by observing those constraints, we can start to build up the solution to the puzzle. So, for example, we can tell that this cell over here on the left-hand side must be the number 9. How do we know that? We know the number 9 must fit into this 3x3 subgrid. We know it can't be in this column here because we've already got a 9. Sorry, in this row here, we've already got a 9 in that row. And it can't be in this row either because we've got a 9 in that row. And there's only one space available left in this top row. So that must be where the 9 goes. And so on and so forth. And that's how we can build up the results of the puzzle. And of course, these puzzles, some of them are easy, some of them are harder, and some of them are really hard. And back in 2012, a Finnish mathematician called Arto Inkala created what we believe is the world's hardest ever Sudoku. He called it Everest. I've never been able to solve this using pen and paper. So I thought I'd set myself the challenge of seeing whether I could build an Anaplan solution to solve it. And the approach I took was using Optimizer. And that's what I'm going to show you today. So let's head over to Anaplan. Okay, so we can see we're in the Anaplan. We're in the old UX because we're going to be flipping between this and the model designer. And what we can see, we're looking at a dashboard. And at the top of the dashboard, we can see we've got our 9x9 grid. And it contains that Everest challenge. So that's been preceded with that Everest challenge. But we could go and update these values for a different challenge. We've got a button called Solve Sudoku. And then at the bottom, we've got another 9x9 grid. And so our intention here is when we click on that Solve Sudoku button, magically, the world's hardest Sudoku challenge is solved. So how do we do it? Let's have a look first at some of the framework elements so that the rest makes sense. Let's quickly go to the lists. So we've got 3 lists that we need to consider here today. We've got rows, columns, and digits. Rows and columns are very similar, so I'm just going to open rows. So if I open rows, you can see I've got rows 1 to 9, and you can see I've used this to create my grids. And we've got a total as well. That's going to be important. Importantly, we've also set up subsets. So we're going to be using these subsets to define those subgrids. And remember, each subgrid is 3x3. We've got 9 of them. So I've grouped the rows into 3 groups of rows. And I've done the same on columns. So if we go into grid view, we can see here, I've got my 9 rows. The first 3 are in group 1, and so on and so forth. And it's exactly the same for the columns. The last grid we need to have a look at is digits, and why we have this will become apparent later. So we know that in each cell we can enter a digit from 1 to 9. So we've got those 9 digits. And if we look in grid view, I've got a property called value, which is formatted as a number and has got the numerical value associated with that item. So let's have a look at the model map. So it all starts with entering our Sudoku numbers. And that's the grid that we saw earlier. It's a really simple module. If we have a look behind the scenes, we can see we've got rows and columns as the dimensions. and we've got this number line item, which is where we enter the number. I've also got a line item where I can set up some of that conditional formatting so that we get the shading where you can clearly see the subgrids easily. Pretty straightforward stuff. If we go back to the model map, the end result is obviously the solution output, and again, the solution output is very simple. It's a grid with columns and rows, and then a number line item, and we can see there's just that one number line item and the conditional formatting as well. We'll come back to that formula in a minute. So far, so simple. We've got our input and we've got our output. So what happens next? So as anyone who's familiar with Optimizer will know, there are several parts to setting up an Optimizer action. The first thing is we need to have a target. And typically with Optimizer, we're either trying to maximize or minimize something. So we've got a module here with our targeting. We also need a variable. So this is the thing that we're changing and that we're trying to the variable that we're changing in order to optimize our target. So in our case, our variables are going to be the numbers that we're putting into the grid. But then we have constraints because, of course, any linear problem needs to have certain constraints that needs to be observed. And you can see we've got a module over here called Optimizer Constraints. And the constraints that we're going to have in this challenge are the constraints of Sudoku. So have we got, is one digit represented one time in each row? Is it represented one time in each column? And is it represented one time in each of those subgrids? And so on and so forth. So we've got a number of constraints. Okay, so let's start by having a look at that variable module. So what we've got in the variable module is we have our same grid. So we've got columns, we've got rows, but what we can also see is we've got our digits in the page. So that's interesting. Why are we doing that? So if we come into the designer, what we can see in the designer is we've got a number of line items. And what the first line item does is it's looking up our enter Sudoku numbers, and it's working out if the number in that particular cell, if the value of that number is equal to the value of the digit we're currently looking at, then we want to put a 1 in there. Otherwise, we put a 0 in there. So let's see that in action. So if I open this back out, and if I choose the original puzzle line item, and I choose digit number 1, what I can see is cell C3 and row R7 should have a 1 in it. And if we go back to our original entry of the Sudoku numbers, C3 R7 indeed contains a 1. So what we've done here is we've converted this grid where we're actually entering numbers, and we've converted it into this different format where we've got row, cell, and digit as a third dimension, and we've got either a 0 or a 1 in each of those intersections to say whether that digit is the digit that appears in that cell. We'll come back to why we've done it this way later, because some of you may be asking, why do we not simply continue to put numbers in the cells? But we'll come back to that in a minute. So we've brought through the results of our original puzzle, and we're storing them in this particular format. The next line item is the optimizer variable. So this is what Optimizer is actually going to go in and change and try out thousands, if not millions, of different numbers in here. So there's no formula in there. That's simply empty. Then what we've got is we've then got another line item which is taking that optimizer variable and it's multiplying it by the digit value. So then what it's doing is it's basically converting it back from zeros and ones into the real numbers. So let's try that out. So if we go to the optimizer variable and let's look at digit 3, for example, and let's say optimizer has decided cell 1, row 1 column 1, row 1 is a 3. So we set that to 1 for true. And then if we go to that next line item, optimize output and numbers, it's converted that back to a 3. And so if we look at that as a total, we see a 3. Okay, so I'm just going to go back and change that back. And it'll become apparent as to why we've done that in a few moments. Great. And then the final line item we've got here is a default value of 0, and this is simply used in an import action to reset all of the values in this line item here. So we've got our optimizer variable. So the next thing to have a look at is what is it that we're trying to actually optimize? So if we go back to our model map, we can see we've got our module called Optimizer Target. This is a really simple module. All this is doing is it's taking the total value from this line item across all digits, all rows, and all columns. Now, we know when a Sudoku challenge is complete, not accurate, but complete, when if we add up all the cells, we should have 9 9s, 9 8s, 9 7s, and so on and so forth, and all of those added together should equal 405. So what we've got in here is we've got the total of all of the cells minus 405, and so the target of our optimization is going to be minimizing this number, because this should be 0 if we've completed the challenge. Great. Let's start having a look at the final piece of the jigsaw, and let's start having a look at some of our constraints. So if I go back to the model map, I can see I've got this module here called Optimizer Constraints. And you can see I've got a list of line items. Each one is a Boolean. Each one has a different dimensionality, and hence why we're getting the little subsidiary view boxes. And each one is testing out a different constraint. So you can see the first constraint is, well, when Optimizer starts putting numbers into our 9 by 9 grid, obviously the first thing we need to check is when it's put a number in a box that was already provided to us in the original challenge, that number needs to be the same. What do I mean by that? When Optimizer puts a number in cell C1, R1, it's got to be 8. It's got to match that 8. So we're going to check that. That's our first constraint. Let's go back to those constraints. The next constraint is, obviously, the way we've set this up by having that 3-dimensional grid with rows, cells, and digits, and setting 0s and 1s in each cell, Optimizer could select 1 for more than 1 digit in a cell, but of course we can't do that. Each cell can only have 1 value, so we're going to check that as a constraint. We then want to check the usual Sudoku rules. So each digit is represented only once in each row, it's represented only once in each column, and it's represented only once in each of those 9 subviews. So in total, we've got 9, 10, 11, 12, 13 constraints that need to be observed. I'm just going to go and show you the formula behind one of those. Let's have a look at each digit represented only once in each row. So we go in and have a look at that. We can see it. The important things to note here are the dimensionality of rows and digits. So we want to do this check for each row and for each digit. So for row 1, I want to check the number 1 appears once, the number 2 appears once, and so on and so forth. So that's the dimensionality of that. It's very important that it's a Boolean, and it's very important that the summary is all, because we want this to only return a true if it's true for all of the digits. But then we've got a really simple formula, and all that formula looks up is it looks up that optimizer variable, and let's come back here and remind ourselves what that is, that optimizer variable, and it checks to make sure that for the digit 3, it only appears once in this particular row. So If we were to set that as a 1, it would be okay. But if we were to have the digit 3 appearing twice in the row, we would get an error because that total is 2, it's not 1. Equally, if it didn't appear at all in the row, we'd get a 0 and we'd also have a problem. Okay, so that's just showing you how we can build those constraints up. Now for the final piece of the jigsaw, let's go and have a look at our optimizer setup. So if we go into actions, we can see we've got a process called solve Sudoku. It's got a single action in there called solve. Let's go and have a look at that solve action, and it's an optimizer type action. So we come in here, we go into edit, we can see it's a linear programming optimization. The objective is to minimize that target, and remember that target is 405 minus the sum of all of the digits in the grid, and that should be 0. The variable is very simply a binary number, either a 0 or a 1, in that grid where we've got rows, columns, and digits. So it's either that digit is either off or on for that cell. And then, of course, we've got all of our constraints. And so you can see all 13 constraints there. And you know, does what optimizer has entered, does it match the original puzzle? Is only one digit chosen for each cell? Is each digit represented once in each row, in each column, and once in each of those subviews? Okay, so now we've set up our action inside our process. If we come back to Sudoku Solver, when we click on Solve Sudoku, what we should see is magic happening in front of our eyes and the world's hardest Sudoku being solved in less than a second. And I can tell you, it's taken me many hours to not get very far with pen and paper. And if we close that, we can see the grid at the bottom has been populated. Let's check a couple of rows and columns at random. So row 4, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Great, that's being observed. Let's check one of the subsquares. Let's check this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's being observed as well. And trust me, I've been through that and I've checked all of them. And we have indeed solved the world's hardest Sudoku using Anaplan Optimizer. Now, if you remember before, what we do is we convert this grid where we very simply just enter numbers, and we convert it into this format where we have rows, columns, and then digits. Why do we do that? Because you may be asking, in our optimizer action, why are we entering zeros and ones to turn digits off and on? Why don't we simply have this choosing an integer between 0 and 9 in a simple grid like the first one we had? And the answer to that is, funnily enough, if you do it that way, you don't have a linear problem anymore. An optimizer can't solve it. And there's a real learning from the experience of solving this problem. And that experience was, sometimes you're trying to solve a problem in Optimizer that on the face of it doesn't appear to be linear. And often the answer to turn it into a linear problem is to use this approach and to use a Boolean type approach where you're either turning things on or off. And often or not, you can find that turns a seemingly non-linear problem into a linear problem. Sometimes you have to take, you have to make a few compromises when you do so. So this has been a bit of fun, but there's a serious message in here as well. I think this is quite a complex optimized challenge, one that involved a few different approaches, and finally turning it into a linear approach by using that binary method was the one that worked. So I hope you found this really useful, and thanks for listening.